Lesson 4 Vlog Script. Problem 1. Detecting light. Welcome back, curious explorers. Today, we're embarking on a journey into the realm of invisible waves, a world where our Arduinos becomes a whisperer of light. Prepare to harness the power of light-dependent resistors, or LDRs, and unlock the secrets hidden within the very brightness of our surroundings. The Invisible Symphony. Sensing light changes. Light, that beautiful phenomenon, isn't just something we see, it's also language our Arduino can understand. Light-dependent resistors, or LDRs, act as tiny translators, their resistance changing based on the amount of light they receive. Solution: a sketch for capturing the light's voice. This code empowers our Arduino to listen to the light. It defines the LDR pin and initializes serial communication for sharing insights. In the loop, open and close parentheses, it continuously reads the LDR's value using analog read or LDR. This value reflects the surrounding light level, giving us a glimpse into the invisible symphony at play. We then use serial.print open and close parentheses to share the LDR's voice with the world, displaying the raw readings in the serial monitor. Wiring wizardry, building the light bridge. Follow the wiring diagram. Ensure you have the correct one to create the necessary connection. Connect the LDR's 2 pin to a voltage divider circuit with a resistor. This circuit creates a stable reference voltage for the Arduino to compare the LDR's changing resistance to. Finally, connect the voltage divider's output point to an analog input pin, A0 in this case. Testing and triumph. Witnessing the light's story. First, upload the sketch and open the serial monitor. Second, shine a light on the LDR and observe the reading jump, revealing the change in the light conditions. Third, experiment by covering the LDR, moving it around, or introducing different light sources to see how it reacts. Fourth, imagine the possibilities, detecting motion, automating lighting, measuring ambient light levels, and more. Congratulations! You've now mastered the art of detecting light with LDRs, opening a new window to sense and interact with the unseen world around you. Keep exploring, keep innovating, and keep whispering with the light. Your Arduino adventures are just beginning. Problem 2. Detecting movement. Welcome back, motion detectors. Today, we're adding a new dimension to our Arduino senses, empowering it to detect even the slightest movements and tilts. Prepare to unlock a world of interactive possibilities with the help of tilt sensors. Staying balanced. Understanding tilt sensors. These clever little devices contain a small conductive ball that rolls around with a chamber when tilted. This movement creates or breaks electrical connections, allowing us to detect changes in orientation. Solution: a sketch for illuminating tilts. This code brings movement to light. It defines pins for 2 LEDs and the tilt sensor's output. It sets up serial communication for debugging and insights. In the loop, open and close parentheses, it reads the tilt sensor value and uses an if statement to determine the tilt direction. Based on the tilt, it activates either LED 11 or LED 12, creating a visual response to the movement. Wiring wizard drive, connecting the sensor. Follow the wiring diagram. Ensure you have the correct one to create the following connections. Tilt sensor's output pin to a digital input pin specified in the code. LEDs anodes to digital pins 11 and 12, cathodes to ground via resistors. Testing and triumph. Witnessing the response. First, upload the sketch and observe the initial LED states. Second, gently tilt the sensor in both directions and witness the corresponding LEDs illuminate, each indicating a different tilt orientation. Third, experiment with different threshold values in the if statement to fine-tune the sensitivity. Fourth, imagine the possibilities, interactive games, security systems, motion-activated devices, and much more. Congratulations! You've now mastered the art of detecting movement with tilt sensors, adding a dynamic layer of interactivity to your projects. Keep exploring, keep innovating, and keep sensing the world in motion. The possibilities are as limitless as your imagination. Problem 3. Detecting motion. Integrating passive infrared detectors. Welcome back, motion enthusiasts. Today, we're tapping into a secret superpower, the ability to detect the presence of life itself. Prepare to unlock the mysteries of passive infrared or PIR sensors and create projects that respond to the movement of people and animals. Seeing heat, sensing motion. Understanding PIR sensors. This incredible device detects infrared radiation, the invisible heat. These incredible devices detect infrared radiation, the invisible heat signature emitted by warm bodies. When motion is detected, they send a signal to the Arduino, allowing us to create interactive experiences. Solution: a sketch to illuminate motion. This code brings to life solution, a sketch to illuminate motion. This code brings life to light. It defines pins for an LED and the PIR sensor's input. In the loop open and close parentheses, it continuously reads the sensor's value. When motion is detected, value goes high. It turns on the LED for a half second, creating a visual alert. Wiring laser drive, connecting to the invisible. Follow the wiring diagram. Ensure you have the correct one. To create the following connections: PIR sensors output pin to a digital input pin special. PIR sensors output pin to a digital input pin specified in the code. LEDs anode to digital pin 30, cathode to ground via resistor. Testing and triumph. Witnessing the invisible. First, upload a sketch and observe the LED initially off. Second, wave your hand or walk in front of the sensor and marvel as the LED lights up. Second, wave your hand or walk in front of the sensor and marvel as the LED lights up, revealing your presence. Third, experiment with sensor placement and sensitivity adjustment to fine-tune detection. Fourth, imagine the possibilities, security system, and interactive display, energy-saving lights, wildlife monitoring, and much more. Congratulations! You've now mastered the art of detecting motion with the PIR sensors, opening a world of possibilities for projects that respond to life presence. Keep exploring, keep innovating, and keep sensing the world around you in a whole new light. The only limit is your imagination.
Welcome back, distance explorers. Today, we're borrowing a trick from nature's most skilled navigators, bats. Prepare to unlock the secrets of ultrasonic distance sensors and create projects that can measure the world around them with sound. Sonic Secrets: Understanding ultrasonic sensors. These incredible devices act like miniature sonar systems, emitting high-frequency sound waves and measuring how long they take to bounce back from objects. By calculating the time it takes from the echo to return, we can determine the distance to the object. Solution: a sketch to measure with sound. This code brings sound to light. It defines pins for an LED and the ultrasonic sensors, trigger, and echo pins. It includes functions to send sound pulses and convert the echo duration to distance. In the loop, it calls the ping function to measure distance, displays it on serial monitor, and flashes an LED at a rate proportional to the distance. Wiring wizardry: connecting to sound waves. Follow the wiring diagram. Ensure you have the correct one to create the following connections. Ultrasonic sensors, trigger pin to digital pin 5. Echo pin to digital pin 4. LEDs anode to digital pin 13. Cathode to ground via resistor. Testing and triumph: seeing with sound. Number 1. Upload the sketch and open the serial monitor. Number 2. Place objects at different distances from the sensor and observe the distance readings changing on the screen. Number 3. Notice how the LED's flashing speed increases as object gets closer, creating a visual representation of distance. Number 4. Imagine the possibilities: obstacle avoidance robots, parking sensors, interactive installations, and much more. Congratulations, Group 8! You've now mastered the art of measuring distance with ultrasonic sensors, empowering your projects to sense their surroundings like a bat in the night. Keep exploring, keep innovating, and keep using sound to see the world in new ways. The possibilities are as vast as space you can measure. Welcome back, Code Wizards. Today, we're tapping into a realm of invisible communication, where data dances through the air and objects reveal their secrets without a touch. Prepare to master the art of RFID, or radio frequency identification, and create projects that interact with the world in a whole new way. Whispers in the Ether: Understanding RFID. These magical devices use radio waves to communicate with tiny tags embedded in objects, unlocking a world of possibilities for identification and tracking. Each tag holds a unique ID, and the reader can decipher it using radio waves, even without direct contact. Solution: a sketch to read the hidden codes. This code bridges the airwaves. It defines constants for start and end bytes, tag length, and data structure. It analyzes serial communication at 2400 baud, RFID's language. In the loop, it listens for serial data, parsing it to extract the tag IDs. When a valid tag is read, it proudly announces the ID to the serial monitor. Wiring wizardry. Connecting to the invisible. Follow the wiring diagram. Ensure you have the correct one to connect the RFID reader's serial output to the Arduino's serial port. Disconnect the reader during sketch upload to avoid interference. Testing in triumph. Witnessing the wireless whispers. Number 1. Upload the sketch and open the serial monitor. Number 2. Bring an RFID tag close to the reader and watch its unique ID appear on the screen, revealing its identity. Imagine the possibilities: access control systems, inventory tracking, interactive displays, smart homes, and much more. Congratulations, Group 8! You've now mastered the art of reading RFID tags, unlocking a world of wireless possibilities for your projects. Keep exploring, keep innovating, and keep conjuring magic for the invisible world of radio waves. The future is in your hands, and it's wirelessly connected. Welcome back, intrepid explorers. Today, we dive deep into the realm of liquid mysteries, where understanding the depths is key. Prepare to unlock the secrets of water level sensors and create projects that monitor the watery world around you. Unveiling the hidden depths. Understanding water level sensors. These ingenious devices utilize conductive traces that change their electrical properties when submerged in water. Each trace acts like a stepping stone, creating a ladder of resistance values that tells us how deep the water is. Solution: a sketch to art the following secrets. Solution: a sketch to chart the flowing secrets. This code becomes a water whisperer. It defines pins for powering the sensor and reading its analog output. In the loop, it calls the read sensor function to determine the water level, sending the readings to the serial monitor. By monitoring these values, we gain insight into depths and can read the changes in water levels. Wiring wizardry. Connecting to the liquid labyrinth. Follow the wiring diagram. Ensure you have the correct one to create the following connections. Sensors power pin to digital pin 7. Sensors signal pin to analog input A0. Sensors ground pin to Arduino ground. Testing and triumph. Witnessing the hidden depths. Number 1. Upload the sketch and open the serial monitor. Number 2. Submerge the sensor in water to different depths and observe the changing readings, revealing the water's secret levels. Number 3. Imagine the possibilities. Monitoring water reserves in tanks, detecting leaks, preventing tanks overflow, automating irrigation systems, and much more. Congratulations, Group 8! You've now mastered the art of measuring water levels with sensors, empowering your projects to become guardians of the liquid world. Keep exploring, keep innovating, and keep diving into the depths of possibility. The challenges of tomorrow may lie beneath the surface, and you're equipped to unravel them.